Hello everyone. Today we'll be going through ASA level chemistry and the topic is masses of atoms and molecules. For this main topic, atoms, molecules and stoichiometry, there are 8 videos in the playlist. You can go through all 8 videos to cover this main topic. Let us move. First of all, fundamental concepts about atomic masses we will be discussing, which is first of all, relative masses of atoms and molecules. What is relative atomic mass? Relative atomic mass is weighted mean mass of an atom of an element compared to 1/12 of the mass of the carbon 12 atom. So, why we are taking carbon 12 atom? It's basically international standard. That's why we are following it. So, carbon 12 is taken as 12 units. So, 1/12 of the carbon is taken as 1 unit. Relative atomic mass is a ratio, so it's not having any units. An example, for example, relative atomic mass of oxygen is 16, relative atomic mass of hydrogen is 1. This is what they have shown in periodic chart also. And relative molecular mass, if we wanted to calculate, we will be adding the relative atomic masses. So 16 plus 1 hydrogen plus 1 more hydrogen, so it will be 18. And 1 mole of water molecules will be 18 grams per mole. So molar mass, we say that it is 18 grams per mole. Then we discuss the concept of isotopes. Isotopes of or atoms of the same element with the same number of protons but different number of neutrons. So their mass number will be different, but atomic number will be same. This is what you need to keep in mind. For example, here we have shown this chlorine with the atomic mass of 35 and 37. They are having same 17 protons in both, and number of electrons are also same 17, but number of neutrons are different. This is having 18 and this one having 20. So number of neutrons are different, and you know that atomic mass is adding protons plus neutrons, hence atomic mass will also be different. So this is percentage abundance like 25%, and this is chlorine 35 is 75%. And if we have to calculate the relative atomic mass, so 35 is 75% and 37 is 25%. So we'll be multiplying this and dividing by 100, and we'll get relative atomic mass of approximately 35.5. The same example we have done on the next slide also. So in detail, we will be discussing there. Now, isotopes and relative atomic masses. What are isotopes? We discussed that they are having same number of electrons and protons, but different number of neutrons. So, if we go through the isotopes of hydrogen, is a protium, deuterium, tritium. Protium is having no neutron, 1 proton only, whereas deuterium is having 1 proton, 1 neutron, and tritium is having 1 proton and 2 neutrons. So we can define that the atoms of the same element with the same atomic number, which is represented by Z, with the different number of neutrons, that is, mass number will be different. So same chemical properties, because electronic configuration will be same. So chemical properties are basing on the outermost shell. So that's why chemical properties will not be differing in case of isotopes, but the physical properties which are depending upon the mass, so those will be different. What are those physical properties? Like density and rate of diffusion, that will be different. Relative atomic mass, how we can define one atomic mass unit is 1/12 of the carbon one twelfth of the carbon 12, right? So the weighted mean mass of an atom of an element compared to 1/12 of the mass of the carbon 12 atom. This is how we can define. The formula for a relative atomic mass is sum of the, if we have percentage abundance, so we will be using that percentage abundance, and we can take the sum of those and then divide by this isotopic abundance, sum of isotope abundance. So this is like we are doing the calculation. 75% multiplied by isotopic mass, which is 35, plus 25% abundance multiplied by 37 and divided by 100, and this will be result into 35.5, which is approximate. So we can say that relative atomic mass of coloring is 35.5. Next thing which we'll be discussing is the mole and Avogadro's constant. We know that a mole is what? Mole is basically SI unit of amount of substance. 1 mole of any substance contains 6.02 into 10 power 23 elementary entities. So they can be atoms, they can be molecules, ions, and electrons. So any of these, but number should be same, 6.02 into 10 power 23. This number is known as Avogadro's constant. So credited to the Avogadro, this is a chemist. So if we have to convert from mass of element to number of moles, we'll have to divide this by the molar mass. And if we have to convert moles into number of atoms, we'll have to multiply this by Avogadro's number, which is 6.8 in 10 per 23. And back conversion, if we have number of atoms or molecules, we will be dividing this by Avogadro's number 6.02 in times by 23, and we'll get number of moles. And from number of moles, if we want to calculate the mass, so we'll multiply this by the molar mass and we'll get grams basically per mole. Its molar mass is in grams per mole. And Avogadro constant, as we discussed, is 6.02 into times per 23. Next is the molar mass. Molar mass is what? 1 mole of a substance. How much mass of 1 mole of a substance? Units are gram per mole, and molar mass of an element is its relative atomic mass expressed in grams. So link to the mass is what? 1 mole of an element has a mass in grams equal to its relative atomic mass. Like for example, sodium from the periodic chart, you can check mass is 23. So 1 mole of sodium will be having 23 grams per mole. And similarly, oxygen O2 will be having 32 because the O2 is 16 plus 16. So O2 will be 32 grams per mole. So formula is what? Formula is number of moles. N is equal to mass m divided by the molar mass. So N is equal to m over m. This is what we need to keep in mind. Now, empirical formula. Empirical formula is the simplest whole number ratio. Atoms of each element in a compound. For example, we can take benzene, which is C6H6, and its empirical or the simplest whole number ratio will be CH. So this will be the empirical formula. And we can see basically atoms. These are atoms, molecules, and ions. And these are, we can write the molecular formula also and empirical formula, the actual number of atoms of each element. We need to check actual number. Molecular mass is actual number of atoms, whereas empirical formula is simplest whole number ratio of atoms. Then relative formula mass, the weighted mean mass of formula unit compared to 1/12 of the carbon 12. So formula mass we are comparing with the carbon 12. For covalent substances, this is the relative molecular mass calculated by adding the relative atomic masses values of all the atoms in the formula. We can take example also like water. Water, in case of water, we have 2 hydrogens. So 2 multiplied by relative atomic mass of hydrogen, which will be 2 into 1, and 1 multiplied by relative atomic mass of oxygen. This will 1 to 16, and the formula mass will be molecular mass will be this one 18.0, which is relative formula mass. Then molar mass connection. So the molar mass of water is 18 grams per mole, 18 grams per mole. Using moles in calculations, we can use moles in calculations also. So mass of one, this is like bridge. It's some bridge technique which we are using, like molar mass of A will be converted to molar mass of B. First of all, if we have mass, we have to convert it to the to the number of moles, and from mole of A to mole of B, and then mole of B will be converted to mass of B by multiplying it by the molar mass of the B. So we can convert into particles also, like mass. If we have mass and convert into number of moles, and then if we want the particles, we can convert the atoms, molecules are ions, which are particles. So we'll have to multiply the number of moles by 6.02 into 10 to the 23. We can convert into volume also into gases, and we can find the volume of the B also, and similarly the number of particles of B as well. So example we take so that you can understand better. So this is what mass of iron is produced from 100 gram of iron 3 oxide. Iron 3 oxide is this one. So how many grams are produced? We can write the balanced chemical equation. Always you need to use the balanced chemical equation for these type of calculations. And we can see that the moles of Fe2O3, iron 3 oxide, are how many moles? These are 2 into 55.8 Fe. This is a relative atomic mass of iron multiplied by 2, and relative atomic mass of oxygen multiplied by 3, and we'll get 159.6, which is grams per mole, molar mass we can say. Then number of moles we can convert this mass. 159.6 will be dividing by the given mass, which is 100. This is 100. 100 will be divided by 159.6, which is molar mass, and we'll get number of moles 0.6266. So we know that 1 mole of iron 3 oxide is producing 2 moles of iron. So this ratio we will be using, and we will be getting 2 moles of iron. So 2 moles of iron will be 2 moles of iron 3 oxide will be what? This will be double of iron oxide moles, and this will be number of iron moles will be 1.2532 moles. This many iron moles will be produced, and we can find the mass of iron, and mass of iron is 55.8 grams per mole, and we'll be multiplying by the number of moles. So we'll get 69.9 grams of iron will be produced. This is how we can do the calculation. Then we need to discuss the empirical and molecular formula also. An empirical formula, is simplest whole number ratio, and we can go through empirical. These are empirical formulas, and these are molecular formulas. So you can check, like for example, if you check this glucose C6H12O6, and the simplest whole number ratio is CH2O. Similarly, you can check for P4O10, and this will be P25. H2O2 is an empirical formula is HO. Some of the molecular and empirical formulas are same, like for example, carbon dioxide and water. These two are empirical formula and molecular formula are same. So empirical formula is simplest whole number ratio of atoms of each element in a compound. Benzene example, we can take C6H12, C6H6, and empirical formula will be simplest whole number ratio, which is CH only. Then molecular formulas are actual number of atoms of each element in a molecule, like C6H6. So multiple is 6. So empirical formula is CH. If we multiply, it's basically C1H1. So if we multiply this by 6, we will get C6H6. So this is how we can find the molecular formula. How to find the empirical formula? Write the masses or the percentage composition of each element, and then we will be divide each mass by its own relative atomic mass and find the number of moles. After finding the number of moles, divide all mole values by the smallest mole number to get the ratio, and convert to the simplest whole number ratio. Then we will be multiplying by this number, and over here So empirical formula will be multiplied by this n and we will get molecular formula. This is how we are doing. And where n is equal to molecular formula divided by empirical formula. So we are done with the topic. Again, I'll have to emphasize that you'll have to go through all these 8 videos to cover this main topic, and subtopic is masses of atoms and molecules. Thank you very much for watching. Take care. Bye.